So next question is, if yt is a solution of 1 plus t into dy upon dt minus 2y equal to 1 and y0 equal to minus 1, then so that y1 equal to minus 1 by 2. So this is differential equation question. So first we write the given equation, which is given 1 plus t into dy upon dt minus ty, which is equal to 1. Here we can write dy upon dt minus t upon 1 plus t into y, which is equal to 1 upon 1 plus t. So this is a linear differential equation. So we can compare, which is comparing the given equation dy upon dx plus py equal to q. So here we can see p equal to minus t upon 1 plus t and q equal to 1 upon 1 plus t. So in this linear differential equation, first we find the integral factor. Now we can find the integral factor. Integral factor, which is equal to e to the power integral of p into dt. It means e to the power p. The value of p, it means minus t upon 1 plus t into dt. Now we can write here e to the power integral of 1 minus 1 upon 1 plus t into dt. And here this minus we can take as common. So here when we integrating, we get e to the power minus t into e to the power log of 1 plus t. Ultimately, the integral factor is e to the power minus t into 1 plus t. Now, we can find the general solution. So, the general solution, which is equal to, we know that, which is y into integral factor equal to integration of integral factor into q plus c. So here the equation, which is the form of t. So here we write y of t into the integral factor values is 1 plus t. Here we can take e to the power minus t minus. So we can take by e to the power t, this form, then which is equal to integral of integral factor. It means e to the power minus t 1 plus t, and the value of q here we see, which is 1 upon 1 plus t and dt plus c. Now this term is cancel here, so which is equal to y of t into 1 plus t divided by e to the power t, which is equal to integral of e to the power minus t into dt plus c. Now, next line. The integration of e to the power minus t, it means it will be become y of t into 1 plus t divided by e to the power t, which is equal to minus of e to the power minus t, then plus c, which is the equation 1. And now in this question we already see here x equal to 0 and the value of y equal to minus 1. Now this value put in equation 1, so we get y of t into 1 plus t e to the power t, here actually t equal to 0, not x equal to 0, t equal to 0, 0, then t equal to 0, here e to the power 0, which is equal to minus e to the power minus 0 plus c. We see that y of 0, 1 plus 0, 1 plus 1, this is totally 1, and this is y of 0 equal to minus 1, and totally it's become c equal to 0. So if here we get c equal to 0, now from equation 1, our equation 1 is y of t into 1 plus t e to the power t, which is equal to minus of e to the power t plus c. Now in this equation, putting c equal to 0, we get y of t into 1 plus t upon e to the power t equal to minus e to the power t plus 0. So here y of t into 1 plus t e to the power t, which is equal to minus e to the power minus t. So here we see that yt, okay, yt into 1 plus t. So here minus e to the power minus t and e to the power t, which is became 1, and y of t into 1 plus t, which is equal to minus 1. So here y of t, which is equal to minus 1 upon 1 plus t. So in question, we see in our given question, here we see so that y of 1, हमको यही शो करना है, y of 1 equal to minus 1 by 2. So when we putting y equal to 1, y equal to 1, which is equal to minus 1 upon 1 plus 1, which is equal to minus 1 by 2. So the value of y1 equal to minus 1 by 2 proved. This is the required form of this question. We get y of 1 equal to minus 1 by